relation between electric current and drift speed, drift drift speed. Okay, so for that, let's consider a, a section of a conductor. Okay, suppose I'll have a conductor, uh, large conductor. I'll not draw like this. I'll have a conductor. So this is one cross section. This is another cross section. Ah, take uniform cross sectional conductor. Uniform cross section. Uniform cross section. A current is I. Drift speed of electron is Vd. Okay. So Cd. Okay. Suppose current is flowing in this direction. So electron will flow in the opposite direction. Okay. No. So current flowing to the right. So electron will flow to the left. So how far an electron will move in time t? The distance covered by an electron, the distance covered, covered, covered by an electron in time t is how much? From this data, you know speed, you know time. So distance is speed into time, v dt. Okay. So imagine the free electrons, those are on the surface, AB surface. In time t, they will travel all along to CD surface. That means this distance is v dt. No? If all the electrons on the surface, this surface, in time t, they come to the surface CD, that means this distance, AC distance, is nothing but v dt. Okay. So during that t time, all the free electrons in this volume ABDC, in this volume, would have crossed this surface CD. Already have crossed the surface CD. No. So only this section of free electrons will cross the surface CD. No electrons to the left would have crossed this surface. No? Electrons to the left, they may come inside this volume, but they cannot cross this surface. No, that's okay. You understand this point? All the electrons, since all the electrons to this from the surface reaches this surface or just cross this surface in time t, that means all other electrons within surface will cross this surface CD in time t. So now calculate what is the current through the CD. Let's find the current through the CD. Current through the CD. For that, current through cross section CD means charge through CD in time t divided by time t. Okay, isn't it? Understand? So that is okay. So that is just q charge flows to the, if q charge flows through the section CD in time t, that is q by t is the current. So what will be the q charge? What will be the q charge? Q will be number of electrons passing through CD, times charge of electron. No, this is the net charge, number of electrons into charge of electron. Okay. Then what is the number of electron passing through CD? Electrons means here I am considering free electrons. So number of, that is I will write n. Okay, number of free electrons passing through CD, that is n, is equal to how many number of electron passes through? Those electrons which are within this volume. Nahin. Thus electrons in the volume A, B, D, C. Okay. If small n is the number density of electron, that means number of electrons per unit volume, no, number of electrons per volume means per unit volume how many electrons are there, that is small n. Okay, then what is capital N? Capital N is the total electrons in this volume, A, B, D, C. No, so N will be small n into volume. Yes, yes or no? Yes or no? Try to understand. Okay, it is number electrons number per unit volume. I need this much volume electrons in this much volume, because this much volume passes in time t. So I have to calculate current in time t. So how many electrons? Now density into volume. It will give me total number of electrons. Okay. So what is the volume of ABCD? ABDC? Its face area is A. This length is, this is a cylinder. The volume of cylinder is its area into length. Area is A, length is B dt. Okay, I got N. If I got N, then what is Q? N into Q E. Then Q is equal to N into E, number of electrons in this volume into charge of electron. So number of electron is N, small n, A, B D T. I'll write the E here. This E I'm writing N E A B D. So this is Q. Then what is I? Q by T. Divide the T here. So N E A B D. So current is N E A B D. So this is the relation between current and drift speed. Okay. So from here we can say that current depends on current. If I am not changing the conductor, if I change the conductor, then this N value will change. Okay. So current depends on drift speed. More the drift speed, more will be the current. Okay. More the drift speed, more will be the current. Less will be the resistance. So there will be less resistance from the material. Okay. This is my relation. Okay. What is current density? Then there is a term current density. What is its magnitude? Magnitude of current density? Sude of current density J, current density is equal to current divided by area. So if I divided by area, so what is left? Any VD. So J is equal to any VD. Here also J is proportional to VD. Current is proportional to A. More the area, there will be more current. Okay. Okay. And we know VD is E by 2M into tau. This relation we already studied in the last session. It's just before. No. Okay. From here we can say VD is proportional to E. More the electric field, more is the grid speed. Rest thing are constant. If I am not changing the material, tau will constant. If I am not changing the temperature, so tau will not going to change. E and M are always constant. So VD is constant proportional to E. So I can write VB is equal to some proportionality constant into E. That means mu is equal to this proportionality constant is equal to VD into drift field by E. This mu is known as mobility. Mobility. There is a word mobility. Yes, of electrons. Okay. So what is mobility? If you see this relation, mobility is just E tau by 2m. No. So mobility is just E tau by 2m. V is equal to mu into E. E rest thing is mu E tau by 2m. No. Mobility. If I use this relation here, VD is equal to mu E here, from here, star. So I is equal to NEA mu E. No, isn't it? And we know in a conductor electric field is uniform, so E is equal to potential difference by distance, B by L. Okay, in a conductor, B is potential difference across L, across CROSS, across length L. Okay, so I is equal to NEA mu B by L. If you want to write this value here, then there will be another. Okay, or not necessary. EM by EE by 2M. You can write here also. Okay. So you will remember at least these 2-3 relations. No? I NEAVD. I is equal to NEAVD. NEAVD. Easy to remember. I is equal to NEAVD. Okay. VD is the drift speed. Okay. Mu is equal to E tau by 10. VD is equal to E tau by 2M. E tau by 2M. E tau by 2M. Okay. Okay. So what is the unit of mu? Unit of mu? SI unit. Mu is equal to speed by electric field. Speed is equal to meter per second. Electric field is Newton per coulomb. Force per charge is equal to force per unit charge. Force is equal to Newton. Charge is coulomb. So Newton per coulomb. No. So this will be into meter coulomb into Newton second. It's SI unit, mobility. So you can also calculate its dimensional formula. Meter is length, coulomb 80, force, try to, is it okay, is it correct? So m minus 1, L will get cancelled, L0, T minus 1, T2, A1. Let me check with my note. M minus 1, L0, T2, A1. So this is your dimensional formula of mobility. So how mobility depends on temperature? How? Temperature. Means if temperature increases, mobility increases. Mobility is directly proportional to tau. Tau is inversely proportional to temperature. That is, it's inversely proportional. More the temperature, less will be the mobility. Just think of the word mobility. It relates to motion. How easily it can mobile from one place to another place. That defines its mobility. If you increase the temperature, it cannot move easily. It will get more restriction, more resistance. So by increasing the temperature, mobility gets reduced. Okay. I hope understand. You can understand enough. Okay. Let's do a small example. Mobility, finish this part. There are few examples. Okay. Better you solve this example. It's already. Yeah.